Welcome everyone in this new lesson of WOMP 3D web software course. Today we're going to enter the actual modeling area and see the basic functions to start moving and handling shapes in space. First of all, click on Create New Project and we get the default work area where we find in the center body already present a sphere joined to a cube from which another sphere is subtracted in the center, and on the left the list of these bodies. But let's go in order and let's go slower. First, let's talk about navigation in space, which is done with 3 simple mouse gestures. To rotate, we have to hold down the left button and move the mouse to rotate around the model. While to simply move in one direction without rotating, that is called pan, we have to hold down the right button and move the mouse as we were dragging in the fixed point that we took with the cursor. Instead, to zoom in or reopen the view, just use the mouse wheel upward to zoom in and downward to zoom out. The icons to the right within the modeling window are other tools for navigation, and these are the cube representing the current viewing angle. So when we use the mouse to rotate the scene, the cube also correspondingly turns, and also by touching the arrows around it, you can jump directly, as you might with a project camera, into the 6 main views: top or bottom, right and left, front and back. Below the navigation cube, we find 3 smaller icons. With the first one, we can toggle between the perspective view, that is the default one whenever we open a new project, with which we see the objects in real life too. So with a precise vanishing point, where we can observe converge all the lines of the floor grid and our body's lines. And then the other option is the orthographic view, where the parallel lines in the model are displayed as parallel even on the screen. So there is no vanishing point, and the floor grid from any side, from any lateral side, becomes a simple line on which our creation rests, and the shapes are flat projection without depth. The icon in the middle, on the other hand, simply allows us to return with the camera always to the center of our scene if perhaps the scene becomes very large. The last one, the snap, allows us ideally to grab with one point of an object we are moving the vertex or any other nearest point of another shape, and like a magnet, it will automatically pull up to it once you get close enough. But we will see this in a moment, because let's move on now to moving no longer the view but the actual objects. For simplicity now, let's delete all the objects present by simply selecting them and pressing delete on the keyboard, and then go up here to the left to add a cube, and then add a second one. By clicking on one of them, we will immediately see the so-called gizmo common to all these types of software, which is nothing but the set of these 3 arrows indicating the 3 Cartesian axes in space along which we can move. X is indicated by the color green, Y by the color blue, and Z by red. So to move an object in a straight line along one direction, we click and hold on one of the X, Y, or Z axis cones and drag with the mouse in the desired direction, as if pulling with a string. Another possibility, on the other hand, is moving along the 3 planes represented by the quad arrows, these ones. So for example, in this case, we can move back and forth, right and left, being sure to stay, however, on the same plane, and this is really useful in many occasions. The third possibility, on the other hand, is in the right-hand tab, where we find the precise coordinates of X, Y, and Z that we can type in manually or slide forward or backward to increase or decrease if we place the mouse over the letter, and this little arrow comes to our aid to do that. Also, if we click on the attach on the playback clip icon, we can bind and then go together the displacement in the 3 directions, which will be increased or decreased all automatically by the same amount. And the result will be the displacement along a diagonal that we have implicitly created. Let us now try to make 2 faces of these 2 cubes fit together perfectly. To do this more easily, we activate the snap option and see that all the vertices turn red, and as we move, we are also shown the color planes always red, blue, and green in a semi-transparency to make it even easier to adjust it. Now we can delete one of the two cubes that we no longer need, and if we look above the vertex, for example, we see that curved arrows will appear, and we call that rotation handles. They allow us precisely to rotate our object in the three different directions, and we see that there appears what we might call a virtual protector, that we have the degrees coloring in red as we rotate. We also have a difference in case we are dragging the mouse to outside of the protector. We see how this thin red line starts from the center, also stretches outside, and it is then possible to rotate freehand degree by degree. Instead, by holding shift, we will have a 45 degrees increment at a time, whereas if we keep within the dial, the shots rotate in 22.5 increments. The panel on the right can also be used for rotations in the same way as before, so either by tapping a given number or scrolling and also tying the rotations together along the three axes. Another important issue to consider is the difference between a global or local system, which can be changed here. That is, if we disable global, we are essentially switching to local. The distinction is so important because in the global system, it takes as its reference the Cartesian axis system oriented canonically in space, so we might say straight, while local takes as its reference the Cartesian axis system oriented as the same body we are considering. So right now the two axes correspond, but if I rotate my cube, the new reference system will be rotated too, and if we try to move it, we see how moving along the x-axis no longer corresponds to moving horizontally, but to moving along the direction of the same edges of the cube. Hovering on the vertices of our shapes, it is possible to scale our object, thus changing its dimensions, but to do this with a rule, it is recommended to hold shift while doing it, by which the object will be scaled uniformly on all axes, maintaining the proportions and changing the overall dimensions. Whereas if we hold down Alt while dragging the mouse, the object will be scaled only in one direction, while the other two sizes will remain unchanged. If we pose at the center of any edge of our body, instead, we will relieve two intersecting scaling planes, whose functions is the same as holding down Alt at the end, that is, to extend the object along only the selected plane. Finally, returning to the vertices, we find these dots, which instead are the rounding handles with which you apply a rounded edge to the object and can drag to adjust the rounding. Unfortunately, it is not possible to round a single edge of this cube over any other shape, but there is an overall rounding. We can also find the same functionality here on the right, where we also find more precise numerical values, and a maximum value will correspond to creating a perfect sphere. Under roughness, we still must analyze the mirror option, thanks to which it is possible to create mirrored shapes. The problem with this functionality, however, is that it is not yet very evolved, so it is possible to use as mirroring planes only those that intersecting identify the origin of the scene, so the center of the scene. So if we try to mirror this cube with respect to x, it will be right to this red line, and equally all the other axes. We can decide how many activate mirroring at a time, and we can also decide to merge the mirrored elements together to blend them with goop, which we will explain more in the next lesson. What we cannot decide, however, is just the most important thing, which is the plane or even just a precise point of mirroring, which could allow us to have much more freedom in creating, not being anchored to the origin of the axis. But surely it will be a future edition of the next updates. Of course, now we look at the cube, but if we go to take a shape that doesn't have all the edges and vertices, such as a sphere or a cylinder or any other, we are met by the outer cage, this one, which will always be a regular hexahedron with which we have all the functionalities we just mentioned. Well, I think that's all for this video. Thank you for watching so far. If you liked, please hit the like button and comment for any question. Subscribe to the channel, and if you like, you can also join a supporter for creating more other videos in the future. So thank you, and see you in the next.